So let's see how it works in terms of analyzing the environment. So basically, it's a web application, so it's easy to deploy and works very simply. So you access your server. So I put some different color for the background so you know which server we're talking about. The blue is the management console. I access the scanner. I log in with my username and password. I see results from previous scan where you can see the key size and the algorithm that you used. You can see the signature, and you can see as well which protocol we were using, TLS 1.2. So we will create a new scan. So you put a name so you can remember what this scan is all about. So here I will just say local web for the test. I will put a description so that you can as well remember. And then we just define the scope we want to scan. So we can use subnet mask very easily or scope list, and we will just scan the port 443. So my scan has never been run, so I can run it now. And we will, scan the host and give the result quickly. So once it's done, you just click on it. And you have a picture that will be most likely the picture of your company with self-signed certificate, untrusted certificate, and maybe different certificate authority in place, different key lengths, different signing algorithm. So you can have a view of the situation. You can view the certificate in question, so see what's going on when it was installed and so on. So the first problem, and as I said, we don't force the trust. So you will choose who you want to trust. So the next step of operation when you scan your environment is to define which is the legal PKI in your company. Because believe me, you will find multiple guys, some in the development environment, they will make their own PKI, some in the IT, they might make their own PKI, some on the network guys, they might make their own PKI. So you will see a chaos, and you can first say, okay, this is the legitimate one, so I will configure the trust.ca. And from that point, I will be able to see how it goes. So basically, I will register CA very easily. I just click on the register CA button. I choose the CA certificate file, so I don't need to interface anything to the PKI or just give me the file. I edit the file, we see the detail, we put the name, so we can know what's going on. If you have a CSP responder, we can put it, and we can as well cache the CRs so that when we do validation, we can do that key of the CRs. So the cache has been downloaded, and we can set how often we want to download it. So now I rescan my local network. Done. My report will have changed. Now, while the certificate is trusted, it might have the CRL check that is trusted and valid. So we start to be in the green light. Our environment is quite nice. The next step is deploy certificates or automate certificates. So we're first going to see one quite well-known and popular protocol now is ACME, which comes from Let's Encrypt initiative. So it is governed by RFCs, so internet standard. It's not something that is cooked on the side of the kitchen. We have qualified some clients. So in the ACME world, you have clients and you have PKI, and basically clients, so-called PKI, and maybe magic happen. So we have the form for most common clients. One of them being my preferred acme.sh. It's a shell script, so you can run this guy everywhere on Earth. WinSertus, it's developed by EverTrust, and it's an open source so that allows you to run ACME protocol on Windows. And it provides Lifecycle, the full Lifecycle, so enrollment, renewal, revocation, of certificate. The client, so Sentinel, ACME, and those guys, they also manage installing the certificate in the application. So if you have an Apache web server, you can use the certificate. If you have Tomcat web server, you need to put the certificate there, modify the configuration file, etc. So those clients will take care of that part. So that's basically if I have a Windows machine, I say I want to enroll server for a certificate for my web server, we will do the magic. The certificate will be there, and the Windows admin will not have any much to do. When we come to certificate, there is validation. The whole point of the certificate is to be sure that you are who you claim you are. If you go to www.yourbank or something, you want to be sure that you talk really to your bank. There has to be some validation before you choose the certificate. The ACME protocol comes with three very common validation methods. One is HTTP. So basically, you will prove that you own the server because you run the program with the previous server that you did. You make the custom directory with the custom file there, and then you can see that all the top of the verify it. So that's your server and you own it. The same logic applies for DNS. So you will have to create a text record in your DNS, and then we can validate that you own the DNS. And there is the same using with the TLS, where you can validate servers which are only accessible through HTTPS. And the thing is, we say it's DevOps ready because it's so easy. Your development team, when they need to roll out a server, they can do it in certificate in the flip on the figure. They don't have any more excuse to say, yeah, let's use the self-signed crap. So how do we do that? Well, first part is to configure the thing. So we will configure Horizon to issue ACME. So it's a web application. We have pre-configured the first elements, the CAs, the profile, the PKI and everything. And we will just make an ACME profile where we basically glue together the different configuration. So I say, okay, I'm going to make a HTTP 01 validation. We can do support the other ones. We can define constraints here. So I say, okay, I want my key size to be 248, 2048. If you want to use elliptic curves, we can decide also, and we can restrict the domains to some environment. So you can control, you can automate, but you can control as well. So we say port 80, and we say I want to use my corporate PK, and that's so easy. That's the way you will configure your ACME environment in your company. So it's like once you configure the PKI, you do it once because you don't have so many PKI, and you just have to configure the profile by linking the blocks together. So the deployment itself, as I said, you do not see. It's just one command line where we configure parameters, which are admin email, DNS name of the server, which IIS we want to bind. And then the magic happens. So ACME generate this challenge, copy the file, install the certificate, and that's it. And it took seconds to do it. So this then you can use as a scheduled task. And if we look at the binding here, I can see view that my server has been, the new certificate has been properly installed. So it's why we say using ACME and using automation will save 75% of your cost, because you still have to make a little effort in the beginning, configuring the command line and configuring the fact that this is going to be a periodic job that you want to run. But after that, it's totally automated. So you don't have to do anything anymore. So we said you need to scan and you need to monitor. So once the certificate has been rolled out, you can run your scan again. So before it was self-signed certificate. If I run my scan, now we're going to see the stuff is becoming totally green. 1, 2, 3, done. And now I see that my server has been properly permissioned with the certificate, and everything is green, and I see which one issued it. So it all looks good. Those reports, as we said, they are on the web, but we can also email them. So if you have, periodic, we can define scans by department, and you can say, okay, scan every department every month and send the email, the CSV file to the people in charge of that department. Last element is revocation. So officially, normally, if you play by the book, when you decommission a server, when you say workload goes to trash, you are supposed to revoke the certificate. I say you are supposed because this one do not happen very, very often, but it should happen. Proper IT process should be say, we're going to decommission the server, please revoke the certificate, please destroy the workload, and so on. So here, I just revoked the certificate. We're going to use ACME to revoke the certificate. So again, it's one command line. It's even simpler because I just need to say revoke my certificate and done. So that's extremely simple to do from the operation point of view. Once it's done, if I scan again my environment, 1, 2, 3, scan, I will see that this certificate has been revoked. So we can really follow the step. If you see that in your environment, there is something weird, unless you are in the process of decommissioning the server, because you should not have revoked certificate. So we do support other protocols. The famous one, Simple Certificate Enrollment Protocol, that was made by Cisco in the beginning and available everywhere. So basically, that enables to issue certificate automatically on network equipment, on MDMs, on some clients that you can run on laptops or stuff like that. And as well, support Microsoft emulation. So SCAP is going to work pretty much the same logic as ACME. When you first enroll the machine, you have to make a little bit of configuration, exchange secrets and things like that. And once it's done, then it's automated and certificate get renewed all the time. If you run a network with VPNs and routers and site-to-site VPN, please use certificate. So because this way, when one of your router dies and you send it for repair or to trash, you can just revoke the certificate of that router and your VPN remains safe. Whereas if you use shared password, as a lot of network guys do, then if the router goes to maintenance and you did not erase the configuration, then everybody knows your VPN shared secret, which is not good. We support the most recent enrollment over secure transport. So it's also governed by RFCs. It does support network equipment as well. It does support specific client, and it's also possible to use command line on Linux with curl and OpenSSL. So it's, again, very open, very simple. It does provide some APIs with OTP authentication, DNS116, so which is a little bit more, I would say, strong than just the plain ACME based on this DNS. And we also support the certificate swap. So you had a certificate, we replace it, and everything would still be working. Microsoft, it's not so open, but it's well known, Windows Certificate Enrollment Protocol. So the Microsoft world is very cool if you are with a single domain. You have one CA, one domain, and you can issue certificate on machines and user and everything very easily. When it comes to forest or multiple domain, then things become to be a lot more complicated with the Microsoft approach. So that's where Horizon will make your life easy, even in the Microsoft world where it's click, 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 because here in a cross-forest setup, you can have multiple forests, one CA, and still roll out certificates to machines and users. We basically support enrollment, but we also support auto-enrollment. You can make a GPO in your Microsoft Word, say, I want to self-enroll authentication certificate for all my users, or I want to self-enroll machine certificate for all my devices, and then out of the box, almost for free, you can run 802.1x on your network with machine authenticating with certificate on the network devices. And we do support renewal, escrowing, and revocation for mainly user encryption certificates with some concern because this is a very tricky topic. And I said before, we also support like proprietary boxes like F5 or other load balancers machines that need to have the certificate inside the machine to do the work properly. So F5, as soon as you have the a REST API above 11.5, which is basically most of the RIT sandboxes, you can do the stuff the same way. Create configuration profile, put data group in data in the data group, and get your certificates. So that's the way it looks on the F5 side. You log into your F5 console, you go to local traffic and set policy SSL client. Yeah, it's the server certificate, but that's why they call it client. It's to be used by the clients, or consumed by the clients, for example. You put a name to your certificate, so for example, tab big IP or whatever. And that's it. And then that's the only thing we put. We don't define anything in terms of DNS names, validity, revocation, anything. Then we're going to make a data group list where basically we will put all those informations, name, stuff to that certificate in the data group. So we have to use the same name. Then we say, I want to put strings in there, and then we will put the information we want. So DNS names of the protected website, because typically on an F5, you have multiple websites protected by one certificate. So you want to be able to define multiple DNS names. So I put the first one, then I will put the second one, DNS2, etc., etc. Then you can put other information like admin email or contract email, so that if something goes wrong, people in theory should be able to use that email to reach you. But it's in theory. And once it's done, that's it. We've configured the F5 to do the magic. So what will happen is the background task will run and see that this information this certificate needs to be done. And if we go back here, we will see that our certificate, so we created an empty one, and now all the information are there. We see the two DNS names we want. We see the email we've put everything there. So it's really done transparently for you. And if we go back to our SSL client certificate here, we can view the same information. All the data has been put inside. It's not super nice, it's F5, but all the data has been done magically. So it's the same as ACME. You make the configuration, you prepare the files, and then magic happens, and the certificate is going to get renewed before it expires and before you get any impact. So mobile device management, we support the three more common ones: iTunes for Microsoft, Jamf, and AirWatch from VMware. And there we will support Revocation on the mobile. So you can, again, put Wi-Fi security easily with your device. Amazon, it's becoming more and more present everywhere, including in the region. And if you have workloads on Amazon, you can use Amazon Certificate Manager. So again, we will enable your internal PKI to issue and put certificate on Amazon Certificate Manager, so that your workloads in Amazon can consume that certificate. And if you look at all I told you, and usually it comes with the questions there, yeah, but what happened with my DMZ, or how can I do things? So we have options here to handle that problematics. The first one is ACME validation. If the ACME cannot talk, then you can use DNS01. You can prove that you own the workload by putting a text record in your DNS. Since it's HTTP traffic, HTTP proxy works very well. You can use ACME through HTTP proxies, and it does work. If you have access to the PKI, or if you need to do scanning across data centers and stuff, of course, we have a satellite option that will basically make a single communication between the EverTrust Horizon and the satellite, and then the satellite to the target devices. And the last element we always see is, okay, you do SSL certificate, but we also have other certificates like code signing certificate or machine certificate, but non-SSL certificate. So basically, we have a script API in place that will enable us to do the scan and feed the scan to Horizon. So you have one centralized view here. So we choose this script approach rather than agent approach, because every time you want to install an agent on an environment, IT security people, they come, where did this agent come from, etc., etc. So we say, okay, this is the script. You can audit the script, run the script, and everything runs fine. And it's not an agent, so if you want to automate the script, please automate. If you don't want to automate, well, you will lose a couple of features. But so it makes the acceptance of the solution by IT people easier. So if we look at the supported PKIs, there's a lot of people there. You do recognize probably GlobalSign, Microsoft, Let's Encrypt, DigiCert, CertEurope. Maybe not CertEurope, it's a little bit European company and company CS Novidis as well. But we support a lot of PKIs there, and basically the number is growing. For public PKIs like DigiCert or GlobalSign, there is one discussion with those guys around the enrollment, because they are audited by the CAB forum to be sure that when they issue SSL certificate, they make sure that you are who you claim you are. So that's the whole enrollment process. So rolling ACME to those PKI vendors needs to be, a lot of contractual discussion, and they need to verify. So it's why it takes a little bit of time, but the list is growing and will keep growing all the time. And so as a summary of the key features here, it's a profile-based configuration. So you will not lose your energy reinventing the wheel every time for every use case. We do support multiple PKIs, we do support multiple certificate templates, and we support multiple deployment modes, as you've seen with ACME and others. We support cryptographic constraints, so if you have regulation that say you must only use SHA-5, for example, we can force that. We check the names, so again, we make sure that you will not be issuing certificate for mycompany.com if you are company2.org and things like that. We have monitoring, we have KPIs. Of course, everything is logged, so you can send that to your corporate log management or your corporate CM and see what's going on and have track record of everything that happens. And the last element is most of the protocols and the deployment mode, we put the certificate, but we also put the trust chain. So it's one word, trust chain, but it makes the life easy in many, many cases when you connect to a website and the website do provide the CA trust. So you've probably seen that when you click and it says not trusted, and you might have the whole list of the CAs and the certificates, and you can see where it's not trusted. If you don't distribute the trust chain, then you just see the certificate of the server and you don't have a clue what's going wrong and what is not going on. So one simple word can change a lot of things in terms of usability for people.